Carrie, thank you so very much for being here tonight. We're so very grateful to have you. And of course, welcome to all of you in the audience. My name is Paige, and I'm part of the community relations team at the Deschutes Public Library. Every month, we explore a different theme in our programming, and this month's theme is islands. Our presenter tonight is Carrie Gordon. She is recently retired from being the Forest Geologist on the Ochoco National Forest and Crooked River National Grassland, U.S. Forest Service, headquartered in Prineville, Oregon. Carrie has a BA in Geology from Central Washington State College, now Central Washington University. She is a registered geologist in the states of Oregon and Washington. And she is also an Oregon Master Naturalist through the OSU Extension program. Carrie has had a lifelong fascination with the land and the rocks, listening to the stories they tell. And Carrie is here tonight to tell us about our local volcanic history. So Carrie, why don't you go ahead and take it away?
All right, thank you. Well, we're going to be talking about islands in time. And one of the things that I've also found, since all of us have been doing a lot of virtual meetings, is that we forget to stand up and stretch. So I want people to feel comfortable to stand up and stretch during this presentation if you need to, because we forget to do that and we get all stiff. So it's something that make yourself comfortable. We are going to be exploring islands. Now, islands generally are features that are surrounded by water. But in our case, these islands are surrounded by land and they are visible above the land's surface. The other thing that we're going to be exploring this evening is that intersection of humans with geology. The presentation this evening we'll talk a little bit about ecoregions. Then we'll move on to talking about the geology and the tectonic history to this area. Then we'll move on to these specific volcanoes that are right here in Central Oregon. I can hear you saying, but there's more volcanoes, and you are right. There are a ton of volcanoes all through the Pacific Northwest and even here in Central Oregon. But these specific volcanoes have all erupted within the last 400,000 years. More specifically, they have erupted during the same time frame as people have lived here in Central Oregon. I had the good fortune to read both this book, and I know it's in our public libraries, The Legends of the Northern Paiute by Wilson Weewa. These stories, as told to Wilson by his grandmother, talk about people and the indigenous people and how they interacted with the land around them. And in some cases, there's a story in here that talks about ice. It's very definitely talking about intersecting a glacier, probably continental glaciation from the type of story. But we also have archaeological excavations that link people living here in Central Oregon. In the case of Fort Rock, Dr. Luther Crespin actually in 1938 found some sandals made out of bark that were in amazing shape, and they were age dated at a little over 10,000 years to about 9,500 years, radiocarbon dated. So we know people were here then. Moving on to current day, these Paisley Caves have been excavated by both Dr. Crespin and Dr. Dennis Jenkins. And Dr. Jenkins has found evidence of people being here over 12,000 years ago. So we know people have been here and in the vicinity of these volcanoes that have been erupting around them. What I'd like you to think about this evening is what did people think about when they saw the glow on the horizon or ash coming out of the sky, or felt the earth quake beneath their feet? What did people think? What was going through their minds? That the world was coming to an end, or this was going to change how they hunted for a while? People have been living with active volcanoes for thousands of years.
Hey, Carrie.
Yes.
This is Paige. I am going to go ahead and stop your video because we are having a little bit of connectivity issues. So I'm going to, okay, just want to let everyone know we will still have the PowerPoint visible, but I'm going to hide Carrie's video in the top corner so that we can hear her better.
I thought that might happen. That's fine. All right. So as we're moving on with the legends of the Northern Paiute and archaeological excavations, we know that people have lived here. But geologic time actually starts a lot deeper than just the last 10,000, 20,000 years. If you think of the Empire State Building as 1,250 feet tall, equivalent to 4.5 billion years, a lot of the geology right here in Central Oregon has actually come about in the last 60 million years. But more importantly, which that last 60 million years is the yellow section on this timeline, geologic timeline. More importantly, the part of geologic time that we're going to be talking about this evening is all the way to the right. It is actually all the way at the edge of this time frame. So there's been a lot of geologic time that has happened prior to this. But we need to talk a little bit about that to set the stage. And before we go into geologic time, what we are going to talk about is making connections. Oregon's ecology is so closely tied to geology. We're talking about this area right here in Central Oregon and actually edging down here into the southeast corner of the state. We are at the apex of these 4 major physiographic provinces. We're pretty much only going to be talking about the high Cascades and the Basin and Range, but each of these physiographic provinces has its own unique character. For those of you that have traveled from Central Oregon off to the Blue Mountains, you know that you get into these granites and these incredibly rich, different rocks. If you go due north, you climb up onto the Columbia Plateau with layers and layers and layers of basalt. Driving down to Burns and down to French Glen, you're getting into what is called the Basin and Range country. And then if you head off to due west, you get into the high Cascades. This evening, we're pretty much just going to focus on the high Cascades to the Basin and Range. That's not to say people didn't travel north and to the northeast, because they did, and that's the evidence that shows in our archaeological record and also in the indigenous people's stories and legends. But for this evening, we're going to focus on the high Cascades and the Basin and Range. North American, oh my gosh, 150 million years ago, the beach was here at the boundary with Idaho. It was completely ocean where we are right here in Central Oregon. Over the last 150 million years, material has been scraped off the diving Juan de Fuca plate and pasted onto the North American plate. Another way to look at that is this cross section. This is the Juan de Fuca plate diving under the North American plate. And as it's diving under, it's scraping off these different pieces of what are called accreted terrains. Just means that they're foreign material that's being attached to the North American plate. But if you notice on top of this, there's only pockets where we can see these really cool rocks that have been accreted because they're covered up by lots and lots of lava flows of different types, and lahars, or just volcanic mud flows, have covered up most of this terrain. So what we're going to be talking about this evening is all of this volcanic material that has been pasted onto this North American plate. One other thing that we need to think about is this tectonic rotation. About 10 years ago, global positioning systems were laid out across the Pacific Northwest and California. And the scientists, the geologists, started finding that these accreted blocks were literally rotating in a clockwise direction and pulling the North American plate apart. You can see where it's all cracked here on the basalts on the eastern end of the Ochoco Mountains. You get down into the basin and range country, and it's literally getting pulled apart and creating these big, huge uplifted ranges and down drop valley bottoms. It's also basically breaking everything apart and squeezing it together. And this is the Brothers Fault Zone. So you see this whole series of faults that are literally deadheading right into the high Cascades. All of the volcanics we're going to be talking about this evening, the different volcanic terrain, is all happening in this fault country and along the crest of the high Cascades. We're going to start in the high Cascades, actually. The high Cascades stretch from the Columbia River all the way down to Klamath Falls, and they actually go north up to Canada and down into California. But the stretch that we're going to be focusing on is this stretch right in here. Our pretty little volcanoes that we see on the crest of the Cascades, some of which just got a pretty little dusting of snow the other day, are all less than 2 million years old. Now, there are older volcanoes along the crest of the Cascades, but volcanoes have a habit of wearing down and eroding away, and after about 2 million years, they're gone. All you really see is the remnant basalt flows, and try to piece together, well, where was the vent that those flows came out of? What we have right now are these really young volcanoes by geologic standards. Before we go too much further, I would imagine most of you are familiar with cinder cones. Pilot Butte, Lava Butte, all those little bumps that are down there around the edges of Newberry are cinder cones. They're very volcanic, eruptive, explosive volcanoes that are very short in stature, and they shoot material up and it spills out over the side. We also have another type of volcano that's called a composite cone. It's made up of layers and layers of lahars and different types of lava flows like andesite, dacite, and sometimes basalt. They're basically a stratovolcano. Think about a layer cake. They're just made up of multiple different types of material. We also have really huge, broad shield volcanoes here in Central Oregon. Shield volcanoes are bulges of layers and layers of lava, generally basalt. It's very runny, fast-moving material that spreads out across the surface, comes up from a central vent, and just flows out over the sides. And we also have something called a lava dome. These are oozings of usually a slow-moving material like rhyolite or obsidian that come bulging up into a crater from a volcano that's blown its top. Think about Wizard Island or the dome that is growing in Mount St. Helens. These are lava domes. These are all volcanoes that we can look across the surface of the earth and see them rising up above the surface of the earth. Two volcanoes that we're going to focus on this evening, two of them. Mount Mazama is 420,000 years old. It's a stratovolcano. So it's the one that's made up of layers and layers and layers of different types of material. Newberry volcano, on the other hand, started life 400,000 years ago, and it is a 618 square mile shield volcano. So all of this material around here is part of that shield volcano. Now, Newberry also has other types of volcanic features within the caldera, but the main body of the volcano started as a shield volcano. So keep these in mind. People weren't rattling around here in the Northwest at this point in time, but these volcanoes were already erupting. Also in this same time, if you've been driven down to Tumalo State Park, you've probably noticed these big cliffs as you drive down the road into Tumalo State Park. These are also 400,000-year-old ash flow. So this is a lahar, and that's what you're looking at here is material that is water-laid, fast-moving, or airfall, and that's this upper beige layer. And this is just telling us that we had some pretty active volcanism, explosive mountains right near Bend also erupting besides Mazama and Newberry. Now we're going to move down to the basin and range country. These are the down drop valleys, which were down here in the Alvord Playa, and uplifted mountain ranges. That's a mile high up to the top of the Steens. That's a big, huge fault, and it extends quite a distance. And you can see that fault scarp right here. This is the Alvord Playa. So we've got this big, huge fault scarp, and we're going to focus on a couple volcanoes, volcanic centers that are a little bit north and a little bit southeast of the Steens, if you've been down to the Steens. These are also part of these fractures and faults, and these faults allow an opportunity for magma to come up and literally explode out of these fissures and make these little volcanic centers. And that's what diamond craters is. Diamond craters erupted 7,790 years ago to about 7,300 years ago. This is an air photo looking down on pretty much the basalt that you can see in this diamond craters center. And then this is some of the other features you can see looking at LiDAR. The interesting thing about diamond craters is when this material was erupting, it made a lot of different features, and one of them is called a maar, M-A-A-R. A maar is where you have molten material coming up through the crust and it erupts into a lake, and it becomes a very explosive feature. Basically just shoots up and ends up leaving this place, this crater, where springs can later fill it in. And there was a study done on the Malheur Maar. Even though there's only about 6 feet of water in this maar, but it was drilled down 50 feet. And in that 50 feet, they found different types of pollen and different types of different ash tephra deposits, which you can actually age date and figure out what's going on. Actually, evidence of water having been in that maar for over 6,000 years. That's a lot of sediment that has filled in this basin. The other thing about diamond craters, if you haven't been down there, it's so worth going because it's an easy way to see fresh young lava. In addition to cinder cones and, which I've got a piece of cinder here that I can't show you, but got cinder cones and you've got Pahoehoe lava, lava. Pahoehoe is some of the material here that we're seeing that looks really big, and it just oozes out and creates this kind of puffy texture. Also have collapsed craters, 90 different features out there at diamond craters. There are also lizards and rabbits and antelope. So people that were wandering through this country 8,000 years ago certainly could find food as they were passing through this country. What does that look like today? I would imagine that some of you have probably been following the Iceland lava flows that are coming up through fissures, and lava flows are flowing out across the landscape. This all started on March 19th of this year. Look at the glow on the horizon. That would have been so eerie for people living around diamond craters, having these lava flows. And as we've seen on the web, people have been able to get fairly close to actually watch the lava moving. The unfortunate part is also the eruptions in Africa that started just a few days ago. These lava flows have been pushing their way up close to people's homes. They've displaced a lot of people. In fact, if you were watching the news in 2018, Kilauea erupted, and those lava flows that came off and out of the vent area at Kilauea literally went down old river drainages, and if there's a road in the way or a subdivision or a transfer station or a cemetery, these lava flows just poured out across. Pretty much you can't really stop them. This is just the way lava works. Kilauea has been dealing with eruptions for hundreds of years. So each one of these eruptions, these colored polygon, represents an eruption that's been going on from 1750 to 2018. So this isn't anything new for the Hawaiian Islands. The cool thing is we can go to diamond craters and get a sense of what it has happened more recently in the Hawaiian Islands. Also during this time frame, we've had alpine glaciation in the last 25,000 years to 10,000 years, and even more recently around 3,000 to 1,000. So I was in the Steens late September one year, and we got caught in a snowstorm looking down Kyger Gorge. This was a summertime view. This was that September view. And it gave me a sense of what those glaciers would have looked like. They would have filled this whole valley and were carving their way down out to the north and to the south and to the west, carving out those big, huge valleys. Think about what that would have meant for people living nearby at that point in time. It would have been a pretty cold environment. But some of these eruptions were happening during that same alpine glaciation period. Moving on down to the southeast corner of the state is another young volcanic center, even younger than diamond craters, 3,200 years old. The reason we know that is because there was they did some drilling along the edge of Jordan craters, and they found some twigs, some charred twigs that they were able to radiocarbon date that literally gave the age of the lava flow above and the stream gravels below. So you knew when that river valley was literally covered up by the lava. The thing about we're seeing here in this LiDAR is this is the old valley edge, and the lava didn't have enough volume to spill out over the top. It basically stayed within that drainage system. Lava runs just like any other flood would do. It stays within a valley bottom until it has enough volume to spill out, just like a flood. Think about the Willamette River flooding. Same thing, except this is molten rock. So 3,200 years ago, that's fairly recent. Let's move back to the high Cascades now and talk about some of the rest of our volcanoes. Here we are with the high Cascades, moving back into this neighborhood now. The volcanism that was the source of the magma for Jordan craters and diamond craters is literally the fissures and molten rock coming up along the fissures. It's a different story for the Cascade volcanoes. These Cascade volcanoes are the result of the subducting plate starts melting, and it literally sweats off water that comes up through the crust, remelts some of the crust, and that's what the source of the magma is for the Cascade volcanoes. So it's a slightly different magma source than along those fractures and faults in central and eastern Oregon. Here we're looking north and south along the crest of the Cascades, and you can see all our pretty big ice cream cone volcanoes. Here we are with Bachelor, Broken Top, and South Sister. These are all less than 2 million years old. They're really baby volcanoes when it comes to the geologic time frame. And during this time frame of these eruptions, we were talking about the last 25,000 to 10,000 years, we had active alpine glaciation, and these glaciers were literally eroding the tops off of the volcanoes. And in some cases, the volcanoes were erupting literally underneath that glacial ice, which makes some pretty interesting features. But for the people living here in Central Oregon, a lot of that happened long before people were wandering through here. This graph is kind of busy, but what it's showing us is all of these volcanic events that have happened in Central Oregon during the last 15,000 years. Starting with, you've got Mount Mazama that we'll focus on, and we'll talk a little bit about South Sister. Lava Butte is on the flanks of Newberry, and we'll focus on the big obsidian flow, which was the last more recent activity here in Central Oregon. So you can see that just here in Central Oregon, there's been a lot of volcanic activity. But before we go too far, Mount Mazama, 7,700 years ago, blew its top, bequeathed us with 100 cubic kilometers of volcanic ash. What does that mean for Central Oregon? Well, in the path of that ash plume, the big coarse pumice fell out. If you've ever looked at the soil around Lapine, it's all pumice soil. That's the stuff that fell out of the ash cloud. If you spend any time in the Ochoco Mountains, 1.5 feet of fine volcanic ash fell across the Ochoco Mountains, and that's what you can still see piles of today. Literally, this mountain blew its top. Well, do we have any analogs for that today? We do. April 9th, La Soufriere volcano in Caribbean island of St. Vincent erupted, shot an ash plume into the air. People's lives have been totally disrupted. Air traffic has been diverted. This ash plume has caused lots of havoc, and that's a recent ash fall. We also know of other events that have caused airlines to detour and even stop. on May 18th, 1980, for those of you who may have lived here in the Pacific Northwest or were in the path of the ash fall, you might remember that Mount St. Helens used to look like this, blew its top on May 18th, and again on July 22nd, and it stayed active off and on ever since. This is what it was looking like in central and eastern Washington. These are some ash clouds moving over Ephrata on the day after the main eruption. This is what it looked like out my kitchen window in Cle Elum, Washington. I could smell sulfur, and the ash coming out of the sky was really eerie. I could see the black cloud, which is what this is. I could see the black cloud going down the ridge just south of Cle Elum. We didn't know what was going to happen, and that was 1 cubic kilometer of ash. For folks that lived in eastern Washington, it caused a lot of problems for quite a while. This is Connell, Washington, 180 miles away from Mount St. Helens. It was covered in ash. This stuff would fly up into the air with just the littlest of a breeze. It's kind of rough living in that ash path for a while after that eruption. Now we're going to move a little closer to Newberry and talk about Lava Butte. This map is literally showing the aerial extent of the lava flows that started 400,000 years ago. We're going to narrow in our focus and look at these last few lava flows that post-date Mazama's eruption, which just means that these lava flows literally flowed across ground that had ash pockets and layers of ash on the ground. Here we're looking at Lava Butte. You can see it's along this rift zone. So for those of you that have been up Lava Butte, it started life as a cinder cone, but it didn't stay a cinder cone. It literally busted out a lava flow out the base of the cinder cone and flowed off to the west, literally damming up the Deschutes River, and it formed Lake Benham. Well, Lake Benham, all that water that would have been flowing down the Deschutes drainage, which got filled in by lava flow, finally burst through an older bit of volcanics and created Benham Falls. So this is some older volcanics where the Deschutes River finally broke through. The Deschutes River has been getting pushed back and forth in its ancestral channel by lava flows coming out of the Cascades from the west and lava flows coming in from the east from Newberry, and it's got shifted around all over the place. But water, being water, has persisted and continues flowing to this day. But there was a massive lake that basically covered over where Sun River is today. And it finally busted through and continued flowing on down drainage. Let's talk about Broken Top, which last erupted 4,000 years ago, and South Sister, which is mainly an andesite, dacite, rhyolite composite cone. It's been alive for the last 50,000 years, but more recently, 2,000 years ago, it erupted with a small lava flow and created this devil's chain of rhyolite domes along this fracture face, as well as a small little basalt lava flow. And that all happened about 2,000 years ago. You can see that little daisy chain of rhyolite domes right here. For those of you that like to drive the Cascade Lakes Highway, there's a couple pullouts right at the base of the toe of this easternmost dome. If you stop and look at the rock, it looks really similar to obsidian, and that's because obsidian is a rhyolite. Geochemistry is rhyolite, and this rhyolite is a very glassy rock, very similar to obsidian. It has that same conchoidal fracture. Newberry. Newberry started life as a shield volcano, but it didn't stop there. There's been all sorts of different types of volcanic cones and vents that have erupted around the Newberry caldera. Got the pumice cone, and we're going to focus in on this obsidian flow, which is one of the last, more recent events at Newberry. It started out with a tephra plume, and then there was an ash flow, and the last gasp was this really cool, slow-moving obsidian flow. Yes, Newberry is considered an active volcano. USGS, US Geological Survey, has considered a very high-threat volcano, and as such, they have placed 12 seismometers and 8 GPS stations around the volcano to monitor for activity. We'll know if anything is happening fairly quickly because USGS is really, with the Vancouver Volcano Observatory Center, they're right on top of letting us know if anything should be happening. Most of the volcanoes that we've been talking about this evening are mainly extinct, if not dormant. So the start of that last big obsidian flow started with this Plinian eruption. That's another way of just saying an ash eruption of volcanic ash, and it shot up to like 11 to 13 miles high. And it was a big, huge column of this ash or tephra and gas. There was a little bit of a pyroclastic flow and then the obsidian flow. So what did that ash fall look like? We had strong, 1,500 years ago, we had strong east blowing winds because there's barely a trace of volcanic ash to the west of the vent. There's about 10 feet of volcanic ash that was measured right near the vent, and it edges out to about a foot deep on either side. So the bulk of it went off to the east and the northeast. What did that look like? Well, think about, and this is what Mount St. Helens looked like. This is what La Soufriere volcano looked like. You had these big, tall ash columns, and the prevailing winds took it off, in this case, off to the east. There was also a bit of a pyroclastic surge that was associated with this eruption a little bit later, followed by the slow-moving obsidian flow. This would have been something that, if you were on the west side up on the Cascades hunting, that would have been a really good place to be and watching this eruption from the distance. This is the Mayan volcano in the Philippines that erupted in 1984. The geologists were able to evacuate 73,000 people. There were no casualties associated with this eruption. Very similar type of eruption to what we would have seen at Newberry. And the last little bit of Newberry is this really pretty obsidian flow, 1,300 years ago. This is slow-moving material. You could have outwalked this particular type of lava flow. If you've had the good fortune of coming up and hiking up onto the big obsidian flow, this is the little pond, a spring, it's a spring-fed pond at the toe, at the base of the obsidian flow. It's right in here on this LiDAR imagery. Now, most of us think about obsidian as being a black, glassy, shiny rock. It is, But it can also show us how plastic the material is as it's moving. And what we're seeing here is some of that plasticity in the rhyolite, the obsidian, as it's moving and easing around on itself. And it really is, it's kind of fun texture to look at when you're hiking through the trail there on the big obsidian flow. The volcanoes that we've been talking about this evening are not the only ones that have been erupting here in the Pacific Northwest. In the last 4,000 years, these volcanoes along the crest of the Cascades have been very active. Lassen Peak erupted in 1917. So we've had all sorts of volcanic activity going up and down the Cascades, and that's in part why we hear so many stories, indigenous stories about earthquakes, volcanoes, lava flows, ash flows, people needing to move away from tsunami country. We just live in a volcanically active area. And a lot of these eruptions have definitely been happening with people living here in the Pacific Northwest. This evening, we've been stretching across just eastern edge of the state with Jordan craters. We've talked about diamond craters. Here's where we know people were living with Paisley Caves and in the Fort Rock area. We've talked about Newberry, Lava Butte, South Sister and Broken Top, and Mount Mazama. So all of these volcanic islands right around us have definitely influenced how people have lived here in Central Oregon. With listening to a talk by Dennis Jenkins a while back, it made me realize that geology and people really do intersect. And I started wondering why, how, what were people thinking? What was going through their minds when they saw those glows on the horizon? Or ash falling out of the sky and hard to breathe? Did they hole up in the caves and try to stay out of eating whatever they had already collected and staying out of that ash? It just makes you wonder how people were living and what they were doing. If you're interested in doing a little more research, Roadside Geology of Oregon by Marley Miller, the USGS Volcanoes website is an amazing place to go check out if you want to see what some of the other volcanoes have been doing over time here in the Pacific Northwest and across the US. As I said earlier on, the Legends of Northern Paiute, as told by Wilson Weewa, is an excellent read. It really gives you a sense of how people were living here in Central Oregon. And Geology of Oregon by Bill and Elizabeth Orr, it's actually, they talk about the whole state. So that gives you a sense of all of our geology across the state. We've been talking about islands in time, and the rocks tell stories of time passing and climate change and cataclysms. We talked a little bit about the 4 physiographic provinces and focused more specifically on the high Cascades and the Basin and Range country. We talked about the geologic story behind these volcanoes, and more specifically about some volcanoes that have erupted in recent time, in the last 400,000 years here in Central Oregon. And we know that people have lived here when the mountains roared. Thank you. And I'm open for questions, and I will turn on my video. And I think Paige will be able to, I'll do a stop screen share here. I'll start up my video.
Wonderful. That was so fascinating, Carrie. And I love all of the visual demonstrations you had for us. It's always good to kind of put into perspective where we are and where all these features are that you're talking about, especially because we're so familiar with them. I know I personally am really familiar with these mountains and stuff from a different view, from the base rather
Right.
than the aerial view that we're seeing from your demonstration. So that was wonderful.
Yeah.
I'd like to invite everyone to put some questions into either the chat or the Q&A. And you can tell us, where have you hiked? Have you seen these in person? I know I was really intrigued by the Newberry flow and the Newberry. And then I also want to be out there and seeing north, south, middle from these different perspectives. So please feel free to put your questions into the chat. I noticed that we heard a little bit about your background, where you're coming from, the Forest Service, geological, your experience there. But how did this journey begin for you? How did you land on geology? How did you come to want to hear the stories of the rocks?
Actually, it was family. We camped out a lot, but more importantly, I had a teacher, 5th and 6th grade teacher, that took us on field trips to the Vantage Ginkgo Museum. For any of you that have lived here in the Pacific Northwest, if you traveled up to Washington, the Columbia River near George is the Ginkgo Museum. And my first introduction in 5th and 6th grade is we saw these ginkgo leaves as fossils. And I went home and was walking down the street next to my grade school, and I was looking at green fossil leaves. I'm going, that looks just like what we were looking at. Oh my gosh, this is a tree that has been around for millions of years. Oh my gosh. So that was one of the things. And then I had the opportunity in college to start taking geology classes, and I just fell in love with the rocks that stories tell. And I'm also a spinner and weaver. So one of the things I forgot to mention, and it's like we might have a question coming up here. One of the things that I forgot to mention is that I was just floored is Dennis Jenkins and the archaeological excavation that was done at Paisley Caves found spun thread, literally spun fibers that were so fine that they had a needle, a bone needle that they had carved that they could thread that through. We're talking super fine thread and super fine needle, and you could only wonder what in the world were they stitching with that needle. That's 12,000 years ago. My gosh. And they were spinning up fibers. They were making the bark sandals. So to me, that is people using our terrain and using the plants and animals that we have around us. So we do have, did we end up with a question down here?
Yes, it says, hi, Carrie, came into the webinar a bit late, so I don't know if you mentioned the geology of Smith Rock. Is that volcanic also?
Well, Deb, no, because, and actually that's something that I know that the Deschutes Public Library has a recording of a talk I did in January. The reason I didn't mention Smith Rock and the Crooked River Caldera is because our story this evening literally starts 400,000 years ago. And because those were the volcanoes that when they erupted later in their life had to have affected people's lives here in Central Oregon. So I had to not talk about a 29.5 million year old caldera because it was sort of like not part of the story. Sorry.
That's great to really put into perspective there, 29.5 million years.
Yeah, that was some of that older geologic time.
Just a bit. As Carrie mentioned, we had the pleasure of hosting her earlier in the year, and you can find her video on the Crooked River Caldera at our YouTube page. You can go to shooteslibrary.org and our YouTube page, and you can find a whole bunch of fun free programs there. And if you'd like to reach out for the program, we would be happy to hook you up, Deb. That's a great little plug. Thank you for walking right into that for us.
So I'm curious, from the folks that are still here, the attendees that are here, how many of you have wandered down to Jordan craters or diamond craters? Because before I went to Hawaii, I felt that my view of diamond craters was about as close as I was ever going to get to Hawaii. And it was so amazing to see that really young, fresh lava. So how many of you have traveled across and checked out some of these places around our central and eastern Oregon? So Jason, yes, I see that you haven't checked out diamond craters, so I would definitely add it to your June trip, because it's not that far away. It's only 2 hours down to Burns and another hour south to French Glen, and on your way past to French Glen, you literally go right past diamond craters. It's worth the road trip, and it's worth the stop. And BLM has a really wonderful tour guide of the craters that you can get ahead of time. And that's one of the fun things about some of these sites that we've been talking about, is there's a lot of brochures and information in Marley Miller's Roadside Geology, as well as brochures and triptychs that are available through the Department of Geology and Mineral Industry. I forgot to mention Dogami also has a wealth of information. Well, I really appreciate you all coming this evening, and I hope next time you're traveling across our central and eastern Oregon, you think about what people might have experienced when they were seeing these erupting volcanoes.
Looks like we got a couple more questions here. What did you see in Hawaii?
So what I saw in Hawaii, and I should have, I had those slides in earlier, and I opted just to focus on the 2018 eruption. But when I was in Hawaii, literally, I was looking at a lava flow on Maui that looked just as fresh and just like diamond craters. It was pahoehoe, there was blocky lava. Because the Hawaiian Islands are moist and tropical on that particular side, there was more soil development, unlike diamond craters where there's not a whole lot of soil development. So you really can see the basalt, even though it's a little over 7,000 years old, it really is fresh. So Hawaiian basalts were very fresh too, but it was that, oh my gosh, this is that same type of shield volcano, lava flow, fissure eruptions. It's just a lot of fun.
Yeah, we have somebody else in the chat who says that the Big Island crater reminds her of Crater Lake.
Yes.
We have another question. How long did Lake Benham exist prior to the breakthrough that caused Benham Falls?
So that's one of the things that I was talking to some folks down at Sun River, and I couldn't find any literature that talks specifically about how long that lake was in existence, but there are ways to calculate the excavation time down through those older volcanics. A similar situation is at Smith Rock State Park. See, Deb, I'm going to get to the caldera yet, but at Smith Rock State Park, when you walk off of the overflow parking area, you're walking off a 400,000 Newberry lava flow. And when you get underneath that lava flow, you get down to a river cobble, which tells us that's the location of the ancestral Crooked River at that point in time. And then you walk on down the hill to the present day Crooked River. So that's one of those where you can start calculating, also figuring out that if that's 400,000 years old, and we've got this 7,000-year-old lava flow out of Lava Butte, we know that it's probably wasn't 7,000 years before it broke through, but it had to have happened within that time frame. So it's one of those cool little studies. So if you know somebody who wants to play with science and sleuth that out, I think that with LIDAR and some of the other fun things, you could probably figure that out. So no, basically I don't have any idea, but I do know that we see these relationships in a lot of different places.
That's a great way of putting that, seeing the relationships. Well, if there are no more questions, I'd like to just say another great thank you so much to Carrie Gordon, our presenter tonight. And once again, we invite you to check out DeschutesLibrary.org, not only for books and materials, but also for all of our other great fun, free virtual programs. We have a lot of virtual programming coming to you at your Deschutes Public Library, and we have a survey as well that we'll be sending out after this. So please let us know what you want to see coming next to your library. Carrie, thank you so much. Everyone out there, have a great night. We hope to see you again very soon.
Thank you, Paige, and thank you, everybody, for attending. Have a good evening and have a fun summer.